Good afternoon, everybody, and welcome to the class. Today, we shall learn about the maintenance of irrigation canals. So, the expected learning outcomes are as follows. We shall learn about what maintenance is, means the definition, and what are different kinds of maintenance. And then, if the canal has a breach, how can we close that? Or sometime river embankment may have a breach as well. Causes of high maintenance and the lessons learned to reduce the cost of maintenance. So here you will first see few pictures which will give you some idea about the delayed maintenance or deferred maintenance, what problems it can cause. For example, here you can see that soil is eroded from the banks of the canal. Here you can see the canal water, and you see vegetation and you see tree growth. This erosion may gradually proceed towards the water of the canal, and ultimately breaching can happen. This picture is actually for the UCC canal, Upper Chenab Canal, at 20 km from the canal head regulator. Moving forward, you see this situation. It's the same UCC canal at 46.3 km, and you see that there is inadequate freeboard. When you have inadequate freeboard, then the water touches the embankments, and embankments start getting eroded, which ultimately leads to the breaching. In this picture, you see some vegetation, particularly this one is water hyacinth. These are the plants which grow in the water, and this tells that the canal has been neglected for a long time. That's why you see significant growth in the vegetation. It's totally undesirable. Here you see some bank erosion clearly, and the cattle's wading in the canal. This is called cattle trespassing. This is not good for the canal cross section. It damages the cross section. This kind of activity is unsuitable. There can be other ways to facilitate animals so that they can take bath in the water, like cattle ghats. We'll see that in one of the pictures later. Here you see another example of lack of maintenance. This picture again belongs to Upper Chenab Canal, and you see deep scour downstream of the fall structure at 50 km. This is basically a fall. The level of the canal is higher here and it's lower, and there is a fall, and here you can see energy dissipators. So right there, when the canal is operating, there is hydraulic jump, and you see a big pond is created because of the scouring. Again, scouring is undesirable because it changes the cross section of the canal. So if we define the irrigation, define the maintenance, the process to improve the deteriorated conditions of irrigation system to keep them in top operating condition. This is basically the thing. Top operating conditions means when the canal was constructed, whatever were the conditions, we want to keep the canal in the same operating conditions, and that's why we have to do maintenance. And what deteriorations can happen in the canal? For example, there can be cracks in the lining, general erosion because the water flows, it takes soil with it, settlement of the embankment or structures, for example, the canal head regulator or the structure at the fall or an outlet. Then there can be encroachment of the freeboard, scour, seepage, sway damage at the animal crossing. All these are the potential problems which can happen in our canal system. Moving forward, let's talk about preventive medicine, preventive maintenance. Sorry. Actually, there are two types of approaches when it comes to maintenance. One is called reactive maintenance, and the other is called proactive maintenance or preventive maintenance. Reactive maintenance is that when there is a problem or there is an accident, then we rush to the canal and try to fix it. In such situations, we always suffer loss because we wait until some problem happens and then we try to fix it. In case of proactive maintenance or preventive maintenance, we try to monitor and observe continuously and see that if there can be some problem, and we try to fix the problem before it happens. This is the best approach, but the challenge in the developing countries is that most of the time people follow reactive approach instead of proactive approach. If I read it from here, preventive maintenance not only it pays dividends in the economical operation of smooth working system, but also means the uninterrupted delivery of water to the command area. Means that if you adopt preventive maintenance, you will save money because you will not suffer loss. If you believe in reactive maintenance, then definitely you are going to suffer loss, and also you cannot ensure uninterrupted delivery of water because, for example, if there is some breach, then you not only lose water but you also lose time, and the supply of the canal will be interrupted. There is a famous saying, a nail in time saves nine, which basically refers to the proactive approach. The objectives of the maintenance, there are three main objectives. One we already discussed, where we want to keep the system in the top operating conditions. The second is to obtain the longest life and greatest use of the facilities of the system by providing good maintenance and timely replacement. So the life of the system can be longer and you can use it to the best. Otherwise, you will keep repairing and the operation will keep interrupting. And if you want to achieve these first two objectives in the lowest possible cost, then you will have to adopt the preventive maintenance. Of course, we don't want to spend more money, so that's why preventive maintenance is the best approach. Moving forward, let's talk about the categories of the maintenance. Basically, there are four categories. One is the regular or routine maintenance. Second is seasonal repair, then annual repair and emergency repair. So first we'll talk about the regular. The regular maintenance is basically everyday maintenance, and it is small work, and basically it is preventive maintenance. Examples can be fixing of the rat holes, rain cuts when there is rain, and then rain cuts are formed in the soil of the embankment, or the maybe the cross section of the canal. If there are any rain holes, we want to fill them. Then if there is any tree which has fallen in the canal, we want to remove it. Repairing the crack in the wall or replacing backfill when the water flows behind the structure. Structure means can be regulator, can be an outlet, or structure at the fall in the canal. Missing the stones or the bricks, replacing the missing stone and the brick in the lining, cleaning the weed or any floating trash in the canal. All these are everyday maintenance or regular maintenance things. And there is a staff of the canal whose job is to patrol along the bank of the canal and see if there is any such small problem. They have tools and they should fix it right there. Okay. Then the next one is seasonal repair. Seasonal repair is it happens when between the two irrigation season we don't need water and the canal is closed. At that time we do this kind of repair. It is basically light maintenance work, and it is accomplished during the canal closure. Who undertakes this? Mostly the permanent employees of the irrigation department, or you can hire some casual labor on daily wages, and they can help us doing the seasonal repair. Uh, so what is included in the seasonal repair? For example, repairing and resetting of the outlet. If you need to close some outlet or need to relocate the outlet, you do that during the seasonal repair. If there is some damaged panel of the lining, for example, concrete lining, you have some damaged panel, you can replace the whole panel. Um, it cannot be done during the everyday, or you can say routine maintenance. Is a little bit bigger work, so you need to do it during the seasonal repair. Removing all obstructions from the bed and the sides and completing temporary repairs. Sometime during the routine maintenance, you fix some problem on temporary basis and then wait for the seasonal repair to fix those problems on permanent basis. So this is referring to that situation. Moving forward, we have annual repairs. Now, annual repair is something which is big. It includes heavy works, and you need to hire some private contractor. Means you have to tender the project, and then contractors bid, and then you award the contract. You may have studied that process in the construction management course. So the contractor, has his own labor, his own machinery, and he can do the job for the irrigation department. It involves the extraordinary or extensive program of replacing the damaged portion of the lining and embankment slopes. Maybe some reach, say 5 kilometer, 10 kilometer long reach, which you cannot do during the seasonal repair that you do in the annual repair. It also includes occasional large desilting works and comprehensive rain cut repair program when required. So large desilting you have to do during the annual repair once in a year. This picture shows desilting during the running canal. There can be some, the same goes here, desilting during the running canal. Some canals have water throughout the year. In such canals, you have to do desilting during the canal, during the water running through the canal. You cannot, you don't have empty canal because you need water throughout the year in such canals. So this is one example of desilting. This is another example of desilting, and this is for the canal we have in Lahore. We also call desilting in our local language as bhal safai. And you see there is no water. The canal is dry for around 3 weeks, and we have machines which are scraping off the soil, extra soil from the bed of the canal. You can sometimes have these templates for smaller size canals. You can have these templates, wooden templates, to ensure that you can restore the original cross section of the canal and removing the silt. You see here the template is placed in the cross section to check whether the cross section has been repaired or been restored to the original cross section or not. You can refer to this file um, to see more details about these pictures. Yes, there is something called bed bars. You see here in the bed canal, partially on the side and partially on the bed, you have this brickwork, which is called bed bar, and you can construct these bed bars at some intervals. For example, 200 meter or so. This this at the bed and the side, this will help us in maintaining the cross section of the canal, original cross section of the canal during the operation of desilting. So if you have these bed bars at regular interval, then those who are desilting the canal will know that up to which limit they have to scrap off the extra soil. This is for smaller canals. For larger branch canals, you have a bed bar in the form of a vertical column around 1 meter by 1.2 meter in cross section and 1.5 meter in depth. Okay, then the last one is emergency repair. We know that there is no time frame for emergency. Emergency can happen anytime, and sometimes you have serious damages or failure. You may have catastrophic problems, and emergencies are not always predictable with respect to time. Emergency mostly happens when you have floods or heavy rainfall, or sometimes the operation of the canal is being done carelessly by the staff. For example, somebody who has a duty of releasing the water in the canal, he may open the gates more than required, and the discharge more than the capacity of the canal would enter in the canal. That can damage the canal. Human actions such as stealing by blocking canal, cutting canal banks and destroying gates, that damages the canal. Stealing is something not very uncommon, and during stealing people damage the canal. Last one is destruction of the freeboard or portion of the lining or embankment by the animals. That may also happen, because when too many animals would enter in the canal, of course the water level will rise. When you don't have freeboard, the water touches the embankments, and when the water start touching the embankments start getting eroded, and ultimately that can reach to breaching of the canal. So if the canal has breaching, for example, you see this is the canal, right here is the canal, this is the canal bed, this is the side, this is the side, and if there is a breach has happened, then you first use some piles, insert the piles in the ground right here, and then you fill the gaps between the piles with some planks or bushes, and then afterwards you create this bund from both the sides, from this side and from this side. You create that bund, and ultimately you close that breach from both the side, and then you compact it in layers so that the breach can be filled. So first objective is to create this bund to stop the water flowing, and then ultimately we will restore the embankment in this part. Okay, here are some examples of breaching. For example, you see the canal is running here, and this part of the embankment has breached, and the water is gushing out to the adjacent areas. This is an example of canal of breach at Tosa Barrage in 2007, and this is an example of emergency repair. Basically, you see some concrete blocks, most probably 1 meter cube, around 2300 kilograms. You know that the density of concrete is 2200 kilograms per meter cube. Then you see big size boulders and some machinery. This breaching has happened, the water is gushing out. So you will see in subsequent pictures that this gap is being closed. So you see the blocks are now on the ground, and you see here some soil as well. So yes, moving forward, you see soil on top of the boulders and more concrete blocks being pushed forward and forward, trying to close the breaching, and you will see gradually it's almost closed right here. You also see this mesh is used on top of these big boulders to keep them in position, because the flowing water can move these boulders from their place. So this is almost close here. Yes, almost close. You see the mesh here again. So this is how we close if close the breach if it happens. And this is of course emergency repair. Now we shall cover the causes of high maintenance. Why our maintenance is high? There are several reasons. For example, first one is operational difficulties of the canal system, misuse and mismanagement of the canal water by farmer, deficiency in hydraulic and structural design, effective construction, inadequate staff, and inadequate funding available for maintenance of the canal. We'll go over all these points one by one. For example, the first one is operational difficulties. Let me read it for you. Many assumptions are made at the planning stage in the design and operation of the canal system, such as duties adopted in the design of canal sections fall short of the peak demand in the field. Means uh, demand is more and the supply is less, because you assumed um, duty of the canal less than what you should have adopted. What is the duty? Let me tell you what do we mean by duty here. Duty of the water. Duty is defined as the area irrigated by unit discharge. Unit discharge means 1 cubic or 1 cubic of water flowing continuously for the duration of the base period of crop. And what do you mean by base period? Base period means from the first watering, means when you do sowing, to the last watering before you harvest the crop. So from the first watering to the last watering, if the water flows continuously, then what area can 1 cubic flow irrigate? Okay, let me read it again. Duty is defined as the area, it's basically the area irrigated by unit discharge, say 1 cubic of water flowing continuously. Continuously means it won't stop continuously for the duration of the base period. For example, from the first watering to the last watering, if the duration is say 100 days, then for 100 days, if the water keep flowing, then what area 1 cubic water or 1 cubic water can irrigate? Okay, and it is measured as hectares per meter cube per second, means hectares per cubics, or it can be acres per cubic. This is the duty of the water. Let's go back to the, okay, let me just give me a minute, please. Okay, so causes of high maintenance. Let's go to the first one, operational difficulties. So what happens is that, for example, in your design, you have assumed smaller value for the duty of the canal, and in the peak demand is short of the discharge. So it means that you will need more water than the capacity of the canal. So if you try to accommodate more water in the canal than its capacity, then definitely it will damage the banks of the canal and you will need more maintenance. Actual conveyance losses, for example, actual conveyance losses, silt load, silt size, discharge released to the canal widely differ from those accounted for in the design of the canal. So when you are operating the canal, the operation is different, and what you assumed in the canal design was different. So that difference will change how the canal would behave when the water runs through the canal, and that difference in the behavior can cause damage to the canal lining and the structure and the cross section, and that will cause higher maintenance. So operation difficulties cause high maintenance. Then the tampering or the theft of the water. Theft is a serious problem. It's a common problem and is a malpractice by the farmer. And this includes the breaching of the canal, tampering with the outlet and the structure. So when somebody tries to, take away water illegally, he does all kind of wrong things with the canal structures. You see a pump has been installed to take out the water. Here you see many pipes which are creating siphon. You also see some damaged part of the lining. All such things are done by the farmers who are trying to steal the water. Then the next one is design deficiencies. Most important aspect of the maintenance of the canal system is the design setup, both hydraulic and structure. Now, um, for example, when you are designing the canal, the parameters which you have assumed, those were not as per reality. So then, of course, when the canal will run, you will practically see that things are different, and on the design, the things were different, so that will cause high maintenance. In the design, in most cases, the effect of sediment transport parameter is neglected. Much of the maintenance work could have been reduced if proper method of design has been adopted. Okay. Although no design method is perfect, and no structure is perfect, there is of course always there are some constraints, and we cannot say that our life of the canal will be trouble free, but making the design as close as possible to the reality or the real life scenario, that will reduce your maintenance. The next one is the defective construction. That is a big problem in the developing countries, because in developing countries, especially for example like our country, the cost of the material is more, and the cost of the labor is less. So contractors always try to save money from the material. For example, they use inferior quality material in the subgrade that will cause the lining to settle, cracked or damaged. Sometimes there is theft of cement and ineffective supervision during the construction. So you have all kind of problems in the construction of the canals that will ultimately lead to high maintenance during the design life of the canal. It increases the maintenance cost and create problems for effective delivery of water to the downstream reaches. Then the next one is inadequate staff and inadequate funding available. This is a very common problem again in the developing countries. We mostly build big projects by getting loans or gathering funds from here and there, and when the project is done, we hardly have any money or very small amount of money to maintain the system. Um, so our irrigation system is among one of the world largest, and to maintain the system we need a lot of resources, human resources, financial resources, material resources, and they are not always available. That's why we have to delay the maintenance, and that also reduces the quality of the maintenance and repair, which makes the frequency of the repair higher and higher. Okay, so maintenance funding available is insufficient to attend every temporary repair without considering the heavy repairs. Okay, so after this we will cover a few of the experiences gained or lessons learned, because the irrigation system in Pakistan is very old, and over the decades we have learned few things that we shall be sharing here. Number one, compaction of the subgrade before lining is key to success of a stable lined section, as many reaches of lined canal in Pakistan have failed due to improper attention to this. Look, when you are placing the lining, the bed material means the material of the banks and the bed needs to be properly compacted. If you are properly compacting it, then your lining will not settle, will not crack, or will be stable, and that will keep the cross section preserved, and maintenance will be less. Second point, in higher water table reaches, concrete lining is has better overall performance than brick or tile lining, and has less maintenance requirement. Water table is high, it means that the chances of the water can push the lining, um, inwards the canal cross section, and that can damage the lining. So if you have brick lining, brick will keep coming off. So in such cases, you should have concrete lining. If the embankments are not properly consolidated, the result in early failure of the canal lining. Of course, consolidation is very important. If there is loose soil, then loose soil gives will cause instability in the canal lining. Inadequate drainage result in the frequent failure of the lining. Look, whenever whatever lining you have, there will always be some seepage, and that seepage water beneath the lining, that can cause pressure on the lining, especially when the canal is empty. So if you have drainage system like the one I showed you for the Ghazi Barotha Canal power channel, that beneath the lining there was a filter material. So if you have a filter or proper drainage arrangement, then your lining will be long lasting. The maintenance of the operation of irrigation canal is becoming a specialized job, and for this a separate cadre of operation and maintenance staff needs to be established. So there should be dedicated people whose job is only to maintain the system. It's a full-time job, it's not a part-time job. Number 6, you see right here, there are kettles um, drinking water from the canal, and you see some steps here, right here in this region you see some steps. So this area which facilitates the animals is called cattle ghat. So you should, if you want to preserve your canal cross section, you should create cattle ghats so that the animal can approach the water without damaging the cross section or lining of the canal. Also, near the canal, wherever you have more concentration of animal, you can create a buffalo wallow. It's like a pond, which which is full of water, which is full of water, and the buffaloes can enter and bathe in the canal in this, instead of going to the canal water and damaging the cross section. Okay. So number 7, a greater number of bridges / crossings should be provided to facilitate the traffic nearby villages to minimize the damage by the animal and the tractors. So there should be more number of crossings, because definitely people have to cross the canal. When there was no canal, there was free movement. Now because of the canal, the movement is restricted. So if you have less number of crossings, those crossings and the surrounding area of the canal will be damaged because of frequent use of that passage. So if you have more passages, then every passage will be used lesser number of time, and that will lead to lower maintenance cost. The last one, plantation on berms of the canal should be discouraged, as this is injurious to the lining. What is a berm? We shall see that maybe next week. Is basically next to the canal trapezoid, the horizontal part on both the sides is called berm. That berm area, horizontal part, if you do plantation, then the uh, roots of those plants or the trees will damage the sides of the canal. So that of course lining of the canal, because the roots spread in all the directions. So we don't want to have plantation on the berms. That will reduce the if you don't have plants, that will reduce the maintenance cost. So these were some of the lessons learned, and this will conclude today's lecture about the canal maintenance. Thank you very much.